This small seed contains a fix to the ever-present issue of hydrophobicity, an environmental concern caused by wildfires that must be subdued. This seed, a legume, is vital in the future of Californians everywhere.
It's a rare condition this day and age to read any good news on the newspaper page. And love and tradition of the grand design, some people say it's even harder to find. Well then there must be some magic clue inside these gentle walls, 'cause all I see is a tower of dreams, real love bursting out in every scene.
Very good soil with a lot of water in it, and then the hydrophobic soil, which took a couple weeks to curate. Now anyways, I'm going to try the hydrophobic test and show you how quickly the water seeps in the good one, and then how slow it takes in the hydrophobic soil. So, goes in pretty quickly. Now for the hydrophobic soil, it takes longer to seep in.
Forests are not really forests anymore. They are instead kindling for large wildfires, where climate change increases the likelihood and intensity of wildfires, causing drier areas to become drier, which make forests perfect for the cause of a fire. The effects a wildfire has on the soil also increases. Earlier, we talked about a hydrophobicity test and hydrophobicity in general. Hydrophobicity is caused by organic materials burning over soil. That soil becomes water resistant. This means that when water is dropped on the soil, or when rainwater or any kind of water is on the soil, it takes longer to be absorbed into the soil, and this can be a huge issue down the line. Just watch what happens here when it starts raining. The hill is empty. There are no vegetation or trees around because the wildfire, which previously burned down all the vegetation here and only left hydrophobic soil in its wake. And now the hydrophobic soil is allowing water to go down the hill, which may cause flooding. This can be our future if we do not stop hydrophobic soil today, but we can stop it with legumes.
In order to counter the effects that hydrophobic soil has on the environment, we conducted an experiment on testing 2 pots of soil. One soil has good potting soil, the other, which through a process of burning it, is hydrophobic. We tested those 2 things, planted legumes in each, had a scale that tested its moisture, and as we waited for its process of growing the legumes, we measured the moisture in each potting soil to see if the hydrophobic soil will come back to its natural state of good soil. So we planted about 2 spoonfuls of white clover seeds into each pot, and with the good soil it had a moisture level of like 10, 9, 8, like really high, and then for bad soil, the hydrophobic soil, it was at a moisture level of 1 or 2 or 3, which is like no moisture whatsoever. But after planting these legumes and through the process of nitrogen fixation, where nitrogen transfers to ammonia, and then the soil starts seeping in that good nutrients and starts becoming better, we see that the bad soil, the hydrophobic soil, is rising up in on the moisture scale. So now the hydrophobic soil and the good soil are now at the same level of moisture, which is what we're hoping to happen. And so now the hydrophobic soil is at levels of 8, 9, 10, which are 10 is the highest. So to see this, we now know that legumes are a natural way to counter the effects of hydrophobicity and end that. So now, in order to counter all hydrophobicity and help our watersheds, we simply can just plant legumes. As we have researched and we have experimented on hydrophobicity and the benefits of legumes, it's revealed that this is an easy and accessible solution to a most prominent problem in our environment. So this is a major concern, and we hope that our educational video, as well as our experimentation and our thorough explanation, shows you what a serious problem this is and what you each individually can do to stop this problem. When to go?
Just go whenever.
This